Good day, Ma'am Janessa. I am Engine Cadet Russell John Coino from BSMAR A second year Antares. I'm here to discuss my performance tasks about 4-step rule and differentiations and integrations. Then here is the example of the 4-step procedures. First, what is an principle of 4-step? First, basically we can compute the derivatives of fx using the limit of definition of the derivatives with the following step. First, find fx plus h, then plug fx plus fx, then h into the limit of definition of derivative. Then, simplify the difference of quotients. Then, take the limit as h approaches 0 of the simplified differences quotients. So here, step 1, write fx plus h and fx. Step 2, compute the fx plus h minus fx, then combine like term if h is a common factor of the term, factor the expressions by removing the common factor h. Then step 3, simplify fx plus h minus fx over h as h is 0. In the last step, we must cancel the 0 factor h in the denominator in step 3. So, step 4, compute. Example, lim fx plus h minus fx over h by letting h to 0 in the simplified expression. Here is the example. Let's fx equals ax squared plus bx plus c. Compute the fx by definition that is used the 4-step process. Step 1, write fx squared plus x plus h equals a x plus h squared plus b x plus h plus c equal to a plus percentage and x squared plus 2 xh plus h2 plus bx plus bh plus c equals to ax2 plus 2a xh and plus ah squared plus bx plus bh plus c. Then step 2, we use the algebra to single out the factor h. Step 2, fx plus h plus fx equals ax2 plus 2axh plus ah2 squared plus bx plus bh plus c minus ax2 plus bx plus c equals to 2ahs xh plus ah squared plus b equals to h 2ax plus ah plus b. Then step 3, cancel the 0. We need to cancel the 0. H is the most important thing in this step. So fx plus h minus fx over h equals to h 2ax plus ah plus b over h equals to 2x plus ah plus b. Then we proceed to step 4. Let h to 0 in the result expression in step 3. So fx equals to lim h to 0 f's fxh plus h minus fx, then over h, then lim h to 0, 2ax plus ah plus b equals to 2ax plus 0 plus b equals 2ax plus b, and that's the answer. So differentiations. What is differentiations? In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding derivatives of functions. Differentiations is a process in math where we find instantaneous rate of change in function based on one variable. The common example is the rate change of displacement with respect to time, called velocity. The opposite finding of the derivative is anti-differentiation. So if x is a variable and y is no longer variable, then the rate of change of x with respect to y is given by dy and then dx, dy over dx. This is the general expression of derivatives of function and is represented as fx equals dy over dx, where y equals fx is any function. So what is an integral calculus or integration? So integral calculus is helps in finding the antiderivatives of a function. These antiderivatives are also called the integrals of the functions. The process of finding the antiderivatives of the function is called integrations. The inverse process of finding derivatives is finding the integrals, and the integral of the function represent a family of curves. Finding both the derivatives and integral form is the fundamental calculus. In this topic, we will cover the basics of integral and evaluation of integral. So, what is integral calculus? So, integral calculus are the values of the function found in the process of integration. The process is getting the fx to fx is called integration. Integrals assign numbers to the function in a way that describe displacement in motion problems, area and volume problems, and so on, that arise by combining all the small data given the derivative f of the function. We can determine the function f. Here the function is called antiderivative or integral of. Example given, fx equals x squared. So derivatives of fx equals fx equals 2x equal to gx. That is the derivative of. Then if gx equals 2x, then antiderivative of gx equals gx equals g squared. So definition of integral, fx is called an antiderivative or Newton's Leibniz integral or a primitive of a function fx on an interval fx equals fx for every value of x in 1. So integral is the represent of the area of regions under a curve. approximately the actual value of integral by drawing rectangles. The definite integral of a function can be represented as area of region bounded by its graph of the given function between 2 points in the line.